Hi everyone. In section 7.3, we learned how to find the LCD of rational expressions and how to rewrite those rational expressions so that they can have the LCD as their denominators. In this section, 7.4, we are going to apply those concepts to try to add and subtract rational expressions. So in this video, I'm going to show you how to add rational expressions with the same denominator. This process is actually really easy. It's just like when you add two fractions with the same denominator, which is, let's call the first fraction p over q, and the second one is r over q. So same denominator, which is q. And we can look at both cases plus or minus here. All you have to do is just add or subtract the numerators, and then we just keep the denominator the same. So let's apply that to these three examples here. First, I want to make sure that the denominators are the same. So in this first one, part A, the denominators are both 3d plus 5. So all you have to do is add the numerators and then just write the LC or the denominator here. And it doesn't look like we can simplify anything further, so this right here is the answer. Second problem, again, denominators are the same. They're both x plus 3. So we're just going to add the numerators straight across here and write the denominator once. And then in the numerator, looks like we can combine like terms, the 2 and the 1, that will make plus 3, and denominator x plus 3. Now the numerator is a trinomial, so we could try to factor that. So I could factor this as, let's see, two numbers multiplied to get 3, add to get 4, so that would be 3 and 1. Now we can only do this if the coefficient of the squared term is 1. If the coefficient is different from 1, then you would need to use the AC method. If it's negative 1, then you just factor out the negative. Okay, so denominator again is x plus 3. Looks like they both have the common binomial factor, which is x plus 3, so we cancel. By canceling, we get the ratio of 1, but 1 times x plus 1 is just going to be x plus 1 as the final answer. One more example. This time we are subtracting. So we are just going to subtract the numerator here. We have x squared, and then minus a negative 5x. So that will become plus 5x. And then minus a positive 24. So that's going to become negative 24. So I want you to be very careful when you subtract two rational expressions. Another way to write this is you are just going to bring the negative sign, the subtraction sign, and then just put that whole second numerator there in parentheses. And then you can then distribute it to this. Okay, all right, so we write the denominator as x minus 3. Let's try to factor this. I see that the coefficient of the x squared term is just 1, so I can just factor, I can just put x in each quantity here and find two numbers such that when you multiply, it'll give you negative 24 and add to get 5. So maybe 8 and 3, and looks like it will be positive 8 and negative 3. And then over x minus 3. X minus 3 cancel. That will give us x plus 8 as the answer here.